The operational theater centered on a set of axes that linked border approaches, transit hubs, and population centers previously affected by attacks on civilian infrastructure, and control of these axes determined both the capacity to project force and the ability to shield humanitarian corridors. The zone combined dense urban clusters, dispersed logistics nodes, and a lattice of rail and highway connections that routed fuel, medical supplies, and repair material toward forward and rear echelons. Geography and built environment constrained maneuver and shaped force disposition, with river crossings, urban belts, and industrial perimeters creating choke points that concentrated traffic and magnified the effect of any interdiction. Engineering assets carried the dual burden of preserving mobility for military columns and of protecting civilian evacuation routes and critical repair teams. Energy and transport infrastructure within the sector represented layered criticalities, where substations, transformer yards, and marshalling yards formed nodes whose denial would produce immediate ripple effects across supply and relief networks, and planners recognized that disruption of these nodes would impose both military and humanitarian consequences that required calibrated operational intent. Defensive arrays emphasized layered protection of urban approaches and of key lifeline nodes, integrating mobile air defense, rapid reaction detachments, and dispersed spare caches to blunt transient strikes while maintaining capacity for emergency restoration. Nonetheless, logistical doctrine constrained the rate at which heavy equipment and replacement components could be moved under contested conditions, exposing temporal windows during which simultaneous pressure could yield disproportionate systemic stress. Commanders on the side executing reprisal measures oriented forces to exploit those windows by weighting reserves toward rapid exploitation and by assigning strike and interdiction tasks to produce functional effects rather than broad territorial attrition. Civil considerations entered operational calculus. Evacuation corridors, hospital energy needs, and water pumping systems carried priority that altered sequencing of engagements and required dedicated security for repair brigades, and the interplay between military aims and humanitarian obligations shaped both target selection and post-strike allocation of restoration resources. Command and control in the theater operated under the expectation of degraded links due to electromagnetic interference and contested communications, and therefore decentralized authority and pre-approved restoration priorities were embedded into orders to allow local commanders and technical directors to act swiftly when lines or nodes were damaged. Intelligence emphasis focused on mapping logistical flows, cataloging spare inventories, and locating critical repair capability so that interdiction could be sequenced to maximize cumulative effect while minimizing collateral harm to purely civilian assets. Engineering reconnaissance validated approach routes and identified feasible bypasses for essential convoys, informing decisions on where to hold and where to contest. The operational posture thus reflected a synthesis of military necessity and constrained humanitarian calculus. The side initiating reprisal action sought to impose systemic pressure on sustainment and command continuity while preserving avenues for civilian relief and for prioritized restoration where feasible, recognizing that control of junctions, ponton assets, and signaling nodes would determine the tempo of both military operations and of civilian recovery. In this environment, mobility choices, protection of bridging assets, and the security of spare caches emerged as decisive factors, and the balance between targeting effect and mitigating civilian impact framed every maneuver and interdiction decision within the theater. Planning and preparation for the reprisal campaign centered on a structured concept that combined precision strike capability, electronic suppression, and limited ground maneuver to achieve operational effect without broad civilian impact. Intelligence and technical directorates produced a composite target map detailing locations of logistical depots, command relays, and storage sites used to coordinate or supply previous attacks on civilian population centers. Reconnaissance units, unmanned aerial platforms, and signals intercept teams verified each location through repeated observation cycles, identifying transport patterns, fuel convoys, and concentrations of communications equipment. The operational plan defined sequential strike packages intended to degrade offensive infrastructure and to neutralize launch or coordination capacity for further assaults. Planners allocated forces into distinct task groups: long-range aviation and missile detachments responsible for deep interdiction, artillery and multiple launch batteries for near-front precision fires, engineering battalions for rapid assessment of strike effects, and security formations to hold access routes and protect humanitarian convoys operating adjacent to target zones. Command directives emphasized proportional targeting and precision engagement. Engagement criteria excluded dense residential clusters and specified safe radii for medical and relief facilities. Each strike echelon was assigned limited ammunition loads to enforce selectivity and to prevent saturation fire that could compromise civilian zones. Electronic warfare units received parallel orders to jam command frequencies, disrupt telemetry, and blind radar arrays in areas from which attacks on civilians had been launched. The planning sequence incorporated extensive redundancy to account for potential degradation of communications once operations commenced, and subordinate commands were granted autonomy to execute pre-authorized strikes if confirmation loops failed under electronic interference. Coordination between air, ground, and reconnaissance elements followed a modular architecture designed to maintain operational continuity even with partial communication loss. Logistics preparation ensured continuous fuel supply and rapid replacement of expended munitions. Mobile depots were positioned at depth along secure corridors, with engineering detachments maintaining road and rail connections against anticipated counterfire. Field medical stations were organized in parallel to the offensive staging areas to provide immediate treatment for personnel and to facilitate evacuation through pre-surveyed routes. Meteorological and topographic data were integrated into mission planning to minimize collateral damage through precision trajectory calculation and to enhance the effectiveness of guidance systems. Contingency plans addressed possible retaliatory attacks on civilian areas by the opposing side, air defense belts and early warning stations were reinforced, and civil defense authorities were briefed to implement shelter and evacuation procedures concurrently with the launch phase. The operational intent extended beyond immediate retaliation to the establishment of deterrence through demonstrable capacity for measured precision. The sequence of operations was designed to produce cumulative degradation rather than isolated strikes, forcing the adversary to divert resources to protection and repair instead of continuation of offensive activity against civilian targets. Rules of engagement stressed that destruction of logistical and command infrastructure must be accompanied by preservation of humanitarian access routes. Engineers were tasked to open alternate corridors if damage to transportation networks obstructed civilian movement. Command staffs conducted coordination rehearsals to synchronize strike timing, recovery of reconnaissance data, and dissemination of post-strike assessments to confirm that objectives were limited to verified military targets. In parallel, information security protocols ensured that operational details remained compartmented, preventing escalation through misinterpretation or unauthorized release of imagery depicting strike aftermath. By the conclusion of the planning phase, strike packages had been fully assembled, reconnaissance patterns confirmed, and reserve echelons positioned to respond to any counterstrike or breach of humanitarian zones. The integration of intelligence validation, controlled escalation parameters, and immediate restoration planning reflected an operational philosophy grounded in proportionality, precision, and prevention of further attacks on civilians through the neutralization of enabling structures and logistical systems used for aggression. The opening phase executed the planned strike packages with concentrated precision aimed at disabling command nodes, interdiction points, and logistical hubs that facilitated prior attacks on civilian targets, and the operation initiated with layered effects intended to create immediate functional denial rather than expansive destruction of populated areas. Long-range fires and aviation-delivered munitions engaged verified military emplacements, command relays, and storage sites, producing rapid rupture of local communications, the destruction of staging areas, and the disruption of supply sequencing that supported offensive sorties. These effects translated into immediate degradation of the adversary's ability to coordinate follow-on actions and to mass resources for renewed strikes. Electronic suppression, employed in parallel, reduced the adversary's capacity to re-establish remote control over dispersed nodes and complicated the tasking of rapid repair teams, forcing reliance on manual procedures that required escorted movement of heavy equipment. The first tangible impact on the ground manifested in halted convoys and installed redistribution of spare components as marshalling yards lost signaling capability and as road approaches suffered crater damage and interdiction fires that impeded heavy lifting equipment. Security detachments rushed to establish perimeters around remaining intact depots, yet many of those perimeters were short-lived when follow-on interdiction focused on preventing consolidation of repair effort. Engineering teams attempting immediate damage assessment were forced to operate under protective screens and to execute rapid triage, prioritizing restoration of critical switchgear required for hospitals and for designated humanitarian corridors while accepting protracted outages elsewhere. The strike phase created a pattern of selective denial that produced both tactical paralysis in forward sustainment and acute stress on civic lifelines, with emergency managers invoking priority allocation frameworks to direct limited generation toward medical and evacuation nodes. Counteractions by the adversary included immediate redeployment of mobile air defense assets to shield remaining logistic hubs and the detachment of rapid response brigades to escort convoys, but these measures were blunted by continued standoff fires and by the obscuring effects of electronic warfare which fragmented command cohesion. The interplay of effects extended beyond direct material damage. Morale and organizational tempo suffered where routine maintenance cycles collapsed into emergency improvisation, and the diversion of security assets to protect repair efforts deprived frontline units of depth and of predictable relief rotations. Where temporary restorations were attempted, they required heavy lifting capacity and specialized crews whose movement along contested routes incurred high operational cost and risk of subsequent interdiction, producing a cycle of partial repairs and renewed denial. Civilian relief operations adapted through rerouted corridors and by concentrating shelter support around powered medical hubs, yet the uneven distribution of available energy exacerbated displacement pressures and strained local governance structures. Command staffs on both sides recalibrated orders in real time, with attackers sequencing interdiction to preempt repair consolidation and with defenders prioritizing protection of humanitarian access and of nodes sustaining critical loads, creating a dynamic of contested restoration where the ability to protect and to move repair assets became as decisive as the initial destructive effect. The initial phase therefore produced not an abrupt collapse but a widened window of operational advantage, a measurable reduction in coordinated offensive capacity paired with an increase in the defender's resource demands for protection and repair, setting the conditions for subsequent maneuver and for targeted consolidation where exploitation of degraded corridors could yield persistent territorial or logistical benefits. The campaign entered a phase of deliberate development in which combined arms maneuver, interdiction and control of communications converged to convert discrete denials into sustained operational effects. Armored reconnaissance advanced along secondary axes to secure choke points and to establish successive blocking positions on approaches to damaged logistic hubs, while mechanized columns pushed to seize rail junctions and highway interchanges that dictated the tempo of spare part delivery and fuel movement. Artillery and rocket fires were employed to suppress repair staging areas and to interdict escorted convoys, shaping movement corridors so that engineering detachments could work only under protective umbrella and at reduced throughput. Fires and counter-battery missions forced repair teams to conduct phased restorations, each requiring secured intervals of movement that attackers sought to deny. Electronic warfare and signal denial targeted relay nodes and telemetry feeds, producing fragmentation of command and forcing manual switching of control cabinets that consumed specialized crews and heavy lifting equipment, thereby lengthening outage durations and creating successive points of vulnerability for interdiction patrols. Control of communications nodes became a tactical objective in its own right, with mobile signal detachments and intercept teams contesting relay points and with command posts shifting to redundant networks to preserve continuity of direction. Where communications collapsed, delegated authorities enacted pre-approved restoration priorities and security allocations, producing uneven patterns of recovery across the theater. Engineering battalions conducted deliberate clearance and route restoration under security screens, erecting temporary spans to bypass damaged fixed bridges and re-establishing limited throughput for fuel and heavy transport, yet these efforts were repeatedly contested by interdiction patrols and by precision fires aimed at ponton assembly points. Interaction between arms was tightly choreographed, strike and fires shaped denial zones, maneuver sealed access and encircled repair loci, and engineers attempted to restore minimal capacity while security formations held perimeter and interdicted relief convoys attempting to penetrate. Reserves were committed to reinforce contested corridors or to exploit seams where defender response lagged, their movement time to avoid piecemeal exposure to residual strike effects and to preserve combat power for decisive containment. Rapid reaction brigades were tasked to secure recovered junctions and to prevent counterattacks aimed at re-establishing repair lines. Logistics elements adapted by dispersing caches and by employing modular mobile generation units staged on alternate axes, maintaining essential services for prioritized nodes while sacrificing breadth of distribution. Medical and casualty evacuation flows were reorganized to rely less on damaged signaling nodes and more on protected corridors, adding pressure to convoy sequencing and increasing the security burden on transport escorts. Secondary effects accumulated as isolated depots suffered fires, as fuel caches became inaccessible and as supply chains elongated. Rerouted convoys traversed longer, more exposed paths that increased the probability of interdiction and delayed delivery of critical components. Industrial throughput declined where generation proved unreliable, curtailing local production of repair equipment and munitions components and forcing reliance on distant manufacturing hubs that themselves required secure transport corridors. Civil administration responded with ad hoc prioritization frameworks that reserved limited power for medical and evacuation nodes and for military logistics, generating a tiered distribution environment that left urban and rural populations subject to rotating deprivation and increased displacement pressures. Defensive countermeasures sought to mass air defense belts to shield repair corridors and to mount counter-battery campaigns to suppress interdiction fires, yet these measures faced diminishing returns where attack sequencing and electronic suppression fragmented command cohesion and where alternate denial lanes remained active. Localized restorations frequently proved transient. Partial reconnections required heavy lifting and specialized crews whose movement along contested routes incurred high operational cost and risk of renewed interdiction, producing a cycle of repair, interdiction and repair that consumed scarce resources. The operation therefore generated a shifting mosaic of contested access in which the side able to protect and to move repair resources gained incremental advantage and in which control of junctions, ponton assets and signaling nodes determined both the tempo of restoration and the opportunities for territorial exploitation. Civilian relief efforts adapted by concentrating shelter and medical support around powered hubs and by routing humanitarian convoys along corridors secured by military escorts, yet the concentration of relief needs created predictable targets for follow-on interdiction and required continuous reallocation of security assets. The interplay of operational and humanitarian imperatives produced persistent friction for defenders attempting to balance front-line resilience with rear area recovery, while attackers refined interdiction patterns to preempt consolidation of repair effort and to maintain pressure on logistic trains. In sum, the development phase transformed initial disruption into a protracted contest over movement and repair, converting technical damage into enduring operational leverage through control of access, communications, and the sequencing of restoration. The campaign reached a phase of culmination in which accumulated interdiction, controlled maneuver, and persistent denial of repair access produced a clear operational advantage and forced the defender into constrained decision cycles that prioritized restoration over maneuver. Sustained attrition of generation capacity and repeated targeting of spare caches compelled redistribution of mobile reserves to escort and protection duties, reducing depth available for counteroffensive action and for predictable relief rotations. This advantage manifested through a reduction in systemic redundancy. Transmission trunks remained intermittently inoperative, transformer inventories were dispersed or consumed, and heavy lifting equipment proved difficult to concentrate without exposing convoys to interdiction, thereby converting repair effort into a contested resource rather than an assured remedy. Command elements translated this functional superiority into territorial leverage by directing maneuver brigades to seize and to hold junctions and rail marshals whose control would perpetuate limitations on the adversary's ability to reconstitute supply lines, and by positioning blocking detachments on alternate routes to prevent rapid reallocation of spare parts. Attempts to localize and to mitigate impact by the defender took several operational forms and were met by calibrated countermeasures. Rapid response repair brigades were massed under military escort to effect prioritized restorations at hospitals, water pumping nodes and designated humanitarian corridors, yet these efforts required secure corridors that often could not be held without committing disproportionate security assets. Temporary restorations therefore tended to remain fragile. Counteractions included concentrated counter-battery missions aimed at interdiction belts, focused air defense redeployments to protect selected logistics hubs and tactical diversion of engineering resources to construct protected bypasses and modular bridging. Each measure achieved localized benefit at the cost of diminishing capacity elsewhere, producing a trade-off that attackers exploited by redirecting interdiction to newly exposed or underprotected nodes. The culmination phase exposed critical vulnerabilities within the defender's sustainment architecture. Spare part stockpiles lacked the breadth to support simultaneous replacement of multiple high-capacity transformers, and replacement logistics were further complicated by damaged signaling in rail yards and by cratered approaches that limited the movement of heavy cranes and lifting vehicles. Fuel rationing affected mobile generation units and constrained prolonged operation of emergency pumps and heating plants, while industrial production of repair components declined in regions subject to rolling outages, creating a feedback loop that extended restoration timelines. The attacker leveraged these systemic weaknesses by sequencing interdiction to coincide with the arrival windows of reinforcements or spare shipments, thereby multiplying the operational effect beyond the immediate material damage. Operational command translated the cumulative attrition into doctrine by institutionalizing a prioritization regime that linked control of energy nodes to the protection of forward logistics. Junctions seized during the campaign were repurposed as staging hubs for reconnaissance, for artillery groupings and for consolidated escort forces, thereby embedding the interdiction advantage into the theater's physical geometry. Ponton bridges and modular crossings, previously expedients for temporary movement, were reinforced and guarded to create semi-permanent corridors that reduced dependence on restored civilian infrastructure and that allowed sustained maneuver without waiting for full grid recovery. Engineering commands adopted rotational maintenance schedules to preserve route integrity under increased load while simultaneously denying salvage or redistribution of key components to the opponent. At the operational level, the culmination created a persistent condition of constrained mobility and of prioritized access that altered defensive calculus. The defender faced continuous choice between allocating scarce protection to repair convoys and retaining forces for frontline resilience, and the repeated necessity to escort logistical movements reduced the pool of troops available for counterattacks and for flexible response. This resource taxation produced a measurable decline in operational tempo where defenders elected to preserve limited restoration capacity, and it opened opportunities for attackers to press territorial objectives in sectors where restoration lagged and where escort burdens thinned defensive depth. The civil-military nexus also reconfigured under culmination pressures. Emergency authorities and military staffs coordinated static allocation of power to sustain essential medical and evacuation functions, and the enforced prioritization exacerbated regional disparities in energy access, with industrial districts and rural peripheries experiencing extended deprivation. Population movement increased along secure corridors toward powered hubs, creating concentrated demands on humanitarian logistics and amplifying the political and administrative burden on local governance structures. These demographic shifts reduced the local labor pool for recovery work and for industrial production, further impeding the defenders' capacity to reconstitute critical assets. Finally, the culmination phase affirmed that infrastructure interdiction, when paired with control of access and with active denial of repair logistics, produced strategic effects that continued to shape operational options long after initial strikes. The attacker's capability to translate technical damage into enduring operational friction demonstrated the potency of combining precision fires, engineering denial, and territorial occupation into a single integrated method of warfare. The result was a theater in which control of energy flow and of key junctions became as decisive as traditional measures of force, and where the defender's horizon for full recovery extended beyond the immediate campaign absent external replenishment of spares and heavy equipment. The final phase concentrated on clearance, consolidation, and methodical assessment to lock in operational gains and to deny rapid recovery. Engineering detachments, security elements, and logistics teams coordinated to clear debris from impacted substations, to mark and secure structurally compromised pylons, and to neutralize unexploded ordnance that impeded recovery operations, while security patrols established layered perimeters to prevent uncontrolled salvage of critical components and to interdict unauthorized movement along repair corridors. Clearance activities prioritized access routes and ponton approaches so that escorted convoys could deliver heavy lifting equipment and replacement switchgear, and these actions were executed under continuous protective screens with artillery and air defense coverage to deter counterstrikes. Where fixed bridges remained serviceable, they were reinforced and traffic regulated to prevent structural overload, and where bridges were irreparably damaged, engineers erected modular spans and established ferry points to restore limited throughput for fuel and spare delivery. Consolidation included the physical occupation of selected distribution nodes and the emplacement of observation posts and interdiction stations to monitor repair activity and to deny adversary recovery teams the ability to assemble unobserved. Captured substations were reconfigured when feasible to supply prioritized corridors that supported forward logistics and humanitarian hubs, thereby converting damaged infrastructure into controlled assets that served operational aims. Assessment teams conducted detailed technical surveys to catalog inoperative transformers, destroyed switchgear, severed transmission trunks, and the status of auxiliary systems such as fuel feeds and cooling loops, producing an inventory that informed subsequent allocation of strike, repair, and protection resources. These audits documented not only material losses but also choke points in heavy lift capacity and in specialized crew availability, revealing where external replenishment would be required to achieve durable restoration. Logistics staffs reconciled consumption rates of spare parts against dispersed stockpiles and evaluated the viability of sustaining mobile generation units under rationed fuel supplies, and the resulting operational ledger guided decisions on whether to permit localized restorations or to maintain denial at specific nodes for strategic effect. Recovery of salvageable material followed strict protocols to prevent contamination and to preserve traceability for inventory control, with recovered items routed to secured depots subject to verification and redeployment under escort. Security measures extended beyond static defense to include active interdiction of attempts to reposition spare caches or to clandestinely repair critical assets. Mobile reaction groups patrolled secondary routes and rail branches where unsanctioned activity was likeliest, and electronic surveillance monitored known frequencies and telemetry channels to detect coordinated repair attempts. Engineering commands instituted rotational maintenance cycles to prevent infrastructure fatigue on improvised crossings and to sustain throughput at reinforced nodes, and these cycles were synchronized with escort timetables to minimize exposure to interdiction. Medical and civil support units maintained forward casualty triage and humanitarian staging areas in powered hubs while coordinating the gradual reintroduction of civilian services in zones designated for controlled restoration, thereby balancing operational security with limited alleviation of humanitarian hardship. Environmental and industrial hazard surfaced during clearance. Damaged transformers and ruptured fuel lines required specialized containment and disposal protocols to mitigate hazard to personnel and to nearby population centers, and explosive ordnance disposal teams prioritized sites where repair activity presented greatest risk. Where industrial plants had been idled by power loss, restoration required coordinated assessment of process integrity and of supply chain viability, and in many instances restart proved contingent on the arrival of replacement components that remained subject to escort and to route security. Civil administration worked in concert with military staffs to implement phased restoration plans that first addressed medical, water pumping and evacuation hubs and then, where capacity allowed, extended limited power to critical industrial facilities supporting repair operations. The consolidation phase also established durable operational advantages through control of logistics geometry. Secured junctions and reinforced ponton crossings became permanent staging hubs for reconnaissance, for resupply and for fire support groups, embedding the effects of interdiction into the theater's physical architecture. Commanders used these hubs to shorten response times for interdiction patrols and to concentrate protection for high-value convoys, while maintaining the option to reapply pressure at selected nodes where adversary restoration efforts showed signs of consolidation. The combined effect of clearance, consolidation and assessment was to transform immediate tactical effects into sustained operational friction by denying rapid recovery, by reshaping logistical flows and by institutionalizing prioritized access regimes that favored military sustainment and humanitarian essentials over broad civilian distribution. Operational records and technical audits from this phase provided the empirical basis for future planning, demonstrating which interdiction patterns yielded enduring impact and which repair protocols afforded the defender the quickest recovery, thereby informing subsequent cycles of targeting, protection and engineering preparation. The campaign's outcome crystallized into a set of interlocking operational and strategic consequences that reshaped the theater and adjusted the parameters of future conflict. Commanders recorded a sustained reduction in the adversary's capacity to project coordinated strikes against civilian nodes as logistical trains, command relays and storage depots used to support such attacks were degraded and required prolonged reconstitution, thus imposing a persistent operational cost on offensive planning. Control of seized junctions and reinforced ponton crossings provided enduring staging hubs that shortened response times for interdiction patrols and enabled concentrated protection for escorted convoys, thereby converting temporary tactical gains into a permanent modification of logistics geometry. The diversion of mobile reserves to escort and protection duties reduced available depth for counteroffensive operations and for flexible rotational relief, compelling a recalibration of force employment that privileged preservation of repair capacity over tempo of maneuver. Industrial throughput in affected regions declined where power scarcity interrupted production of repair components, creating a feedback loop that extended restoration timelines and increased dependence on distant manufacturing hubs and external replenishment. Civil administrations adopted prioritization regimes that routed limited generation to medical and evacuation nodes and to military logistics, producing unequal distribution that accelerated population movement toward powered hubs and that strained humanitarian logistics along secured corridors. The reallocation of resources toward protection and restoration generated measurable attrition of specialized crews and heavy lifting assets, with replacement cycles elongated by contested transport nodes and by disrupted signaling capabilities at marshalling yards. At the operational level, the campaign demonstrated that targeted interdiction coupled with control of access can achieve effects analogous to territorial encirclement by inducing systemic denial without massed frontal engagements, thereby widening the conceptual space for future planners to shape theaters through infrastructure engagement. Doctrine adapted accordingly. Force planners began to integrate energy security, distributed redundancy and hardened logistics as central elements of sustainment, and engineering commands expanded mandates for forward prepositioning and for modular bridging to reduce vulnerability to timed interdiction. Politically, the operation produced pressure on administrative centers to reconcile emergency allocation with civilian protection, provoking governance choices that altered regional autonomy over energy distribution and that influenced population movement and labor availability for reconstruction. Internationally, the demonstrated vulnerability of energy and logistics networks increased demand for external assistance in heavy equipment and spare parts, shaping diplomatic and material support patterns and prolonging the period before full recovery could be achieved without significant outside inflows. In aggregate, the reprisal campaign achieved a shift in the balance of initiative by elevating control of infrastructure to a primary mechanism of coercion, and by forcing adversaries to weigh the costs of sustaining offensive capability against the exigencies of protecting and restoring critical lifelines. The enduring implication is that future contests will situate energy flow and access control at the center of operational calculus, requiring new investments in redundancy, protection and resilient logistics if long-term strategic autonomy is to be preserved.